Hey guys, in this lesson we would understand what is Kb for a weak base and how to use Kb to calculate pH, or how do we calculate Kb if we are given the pH. Now let's first understand what is meant by Kb. Just like acids, bases also have ionization constant, and ionization constant for a base is called Kb. If we have any weak base, then the base would react in the presence of water. This is excess water. Base is in aqueous state. Then the weak base is going to take up hydrogen ion from water to become BH positive aqueous and OH negative aqueous. In this case, if we write down equilibrium equation, then Kb would be equal to the concentration of BH positive times hydroxide ion divided by base concentration. Here also we are supposed to have BH positive concentration at equilibrium, hydroxide ion concentration at equilibrium, and base concentration at equilibrium. Also, equilibrium concentration of hydroxide ion can be used in the formula negative logarithm of OH negative ion to give us POH, and then we can use this POH to find out pH using the relationship pKw equal to POH plus pH. Because pKw is 14, POH once known can give us pH value. So we can use this formula to either get the value of Kb if we are given the equilibrium concentrations of these three entities, or if we are given Kb value and these two entities, then we can find out the OH negative ion concentration. Once we know that concentration, we can get the value of POH, and then from POH we can get the value of pH. Let's understand all this with an example. So in this question we are given aniline solution, C6H5NH2 aqueous solution is aniline solution that contains 5 grams per liter of aniline is prepared, for which the pH is determined to be 8.68. We are supposed to calculate the base ionization constant, that is equal to Kb value. Now what are we given is, we are given the pH, that is 8.68, and we are given the initial concentration of aniline to be 5 grams per liter. We know in order to find out Kb, we need the equation first. So the equation would be C6H5NH2, it's aqueous, reacts with water, liquid, to give us, because this is a base so it will take H positive from water, to become C6H5NH3 positive plus OH negative. We also know Kb would be equal to the concentration of C6H5NH3 positive times OH negative ions divided by C6H5NH2 concentration. However, we need all of these concentrations at equilibrium. So we would be using this initial concentration and making ice table for this reaction in order to get the concentration at equilibrium. Also, we would be using this pH to get POH, and from POH we would get hydroxide ion concentration at equilibrium. That hydroxide ion concentration at equilibrium can be used here, and we'll see where else can we use that hydroxide ion concentration at equilibrium. However, one thing we have to notice here, that we are given the concentration, that is initial of aniline solution, is 5 grams per liter. It is in grams. We are not supposed to have concentration in grams. It has to be moles per liter in order to put it in ice table. So our first step is to change this 5 grams per liter to moles per liter. Now 5 grams per liter means we are given the mass of aniline, that is C6H5NH2, equal to 5 grams, and we are given the solution volume in which this aniline is dissolved, which is definitely water, to be 1 liter. In order to find out concentration in moles per liter, we have to change these grams to moles. Always remember, in order to change grams to moles, we use this triangle, grams moles triangle. This is grams, this is moles, and this is molar mass. So we would have to divide the grams with molar mass in order to get the number of moles. Therefore, the number of moles would be equal to mass of aniline given to us divided by molar mass of aniline, that we would calculate from the periodic table. Mass of aniline given to us is 5.0. When we calculate the molar mass of aniline, we get 93.14, and this would give us 0.0537 moles. Now concentration is number of moles divided by volume. Number of moles is 0.0537 divided by volume is 1 liter. So this would give us 0.0537 moles per liter. We can write this equation again. Now for making the ice table. So we have initial concentration 0.0537. This we do not have to consider. This is 0. This is also 0. Changes, make sure reaction is balanced, and it is a balanced reaction. So this is minus x plus x plus x. Equilibrium is 0.0537 minus x, and this is x and x. Therefore, now our Kb equation would be equal to the concentration of OH negative ions times the concentration of C6H5NH3 positive divided by the concentration of C6H5NH2. This would give us x times x divided by 0.0537 minus x. Now, if we know the value of x, we can substitute it everywhere to get Kb. We notice here that x can be found out if we know OH negative ion concentration, and OH negative ion concentration can be found from the given value of pH. So pH is 8.68. We would use this pH to get the value of POH, that is equal to pKw minus pH, which is 14 minus 8.68, that is equal to 5.32. Once we know the value of POH, we can put it in the formula of POH to get the concentration of OH negative ion. This is 5.32 minus logarithm of OH negative ion. Now we would isolate this in the same way as we isolated for H3O positive in the previous lesson. So we would take negative on the other side. This would give us log, no base means base is 10, OH negative ion concentration. So 10 to the power of negative 5.32 is equal to OH negative ion concentration, and we get the concentration to be 4.79 times 10 to the power of negative 6 moles per liter. This is what we get after we put this on the calculator. Now we know POH has given us the concentration of hydroxide ion at equilibrium, so we can use this value as x. Therefore, now we know that x is equal to 4.79 times 10 to the power of negative 6. And this x value can be used in this formula to solve for Kb. All we have to do is just put this all on the calculator to get the Kb value as 4.3 times 10 to the power of negative 10. Therefore, the final answer Kb is equal to 4.3 times 10 to the power of minus 10. And this is how we solve for Kb if we're given pH of a solution. Similarly, we can find out pH when we're given the Kb value. Let's take that example as well. Let's say we are given morphine, that is C17H19NO3 solution, which is a solution of a weak base, has a concentration of this. Determine the pH of the solution if Kb for morphine is given to us as this. Now we know that this is a weak base, so this will undergo equilibrium equation. However, we are given the concentration which is not stated as an equilibrium concentration. So this means this is initial concentration of morphine solution. So let's write on what is given first. We are given initial concentration of morphine, and that is equal to 0.01 moles per liter. As we know, this is a weak base, so it would give us OH negative ion concentration at equilibrium when we put this in ice table. From OH negative ion concentration at equilibrium, we can find out POH, and we can then use that POH to get the pH value. So for doing all this, we first need the ice table. We have morphine C17H19NO3 that reacts with liquid water to give us C17H19NOH positive plus OH negative. All of these states would be aqueous because these are ionic states, and this is a solution. So this is ICE for ice table. Now we're given initial concentration of morphine solution to be 0.01. We'll put it here. You do not have to use H2O liquid. This is going to be 0, this is going to be 0 initially. This is minus x, this is plus x, this is plus x as well. Equilibrium concentration will be 0.01 minus x. This is x and this is x. So Kb would be equal to concentration of this times the concentration of OH negative ion divided by the concentration of C17H19NO3. This is NO3 here. Now we would have to substitute the equilibrium concentration. So this is x and x for the numerator. We have x times x divided by 0.01 minus x. Kb value is given to us as 7.5 times 10 to the power negative 7. Now we have to isolate for x. We can apply hundreds rule on this because equilibrium constant value is really small. Therefore, this can be considered as 0 and we would be able to get x squared over 0.01 equal to 7.5 times 10 to the power negative 7. When we multiply this and take the square root of the thing, we'll be able to get x. So this would give us 7.5 times 10 to the power negative 9. Square root is equal to x, which is going to give us x equal to 8.7 times 10 to the power negative 5. Now this x is 8.7 times 10 to the power negative 5, which is hydroxide ion concentration at equilibrium. This concentration would help us calculate pOH value, which is negative logarithm of 8.7 times 10 to the power of negative 5, and we get pOH equal to 4.06. However, the demand of the question is pH and it's not pOH. Therefore, we can get pH equal to 14 minus 4.06. That is equal to 9.94. And this is our final answer.